Hi, I am Varun Joshi and welcome to day 32 of our Certified Kubernetes Administrator 2025 course. This is part 2 of our 4-part TLS in Kubernetes Masterclass. In this session, we will explore what Mutual TLS is and how credentials are structured and managed using the kubeconfig file and the Kubernetes context. What is mTLS? It is an extension of standard TLS where both the client and server authenticate each other using digital certificates. So if I scroll to the left, I have a user schema. I have the API server. API server is the entry point to our Kubernetes cluster. Anything that connects to our Kubernetes cluster from outside first interacts with the API server as it is the entry point to our Kubernetes cluster. Then we have etcd here. Etcd is the data store of our Kubernetes cluster. Then here is our user schema who wants to run a command kubectl get pods. Now, when schema initiates this command, schema is a client and API server is the server. But to get the output of kubectl get pods, API server will in turn have to communicate with etcd, and etcd is the server in that scenario with respect to API server. etcd gives the data and API server then gives that data back to schema, and schema knows how many pods are running in her cluster. That is a simple communication flow. But with mTLS, which is there in Kubernetes, both server and client prove their identity. So if schema wants to connect to the API server will first prove its identity and then schema will prove her identity. Once schema verifies that API server is what it says it is and the API server verifies that schema is what she says it is, then the connection moves forward. Similarly, when API server communicates with etcd to get the desired data, then as well first etcd will prove its identity to API server and then API server will prove its identity to etcd. So this is at a very high level what mutual TLS is. Both client and server are proving their identity. Now let's see how this is different from one-way TLS that we see when we are accessing any public facing websites. When it comes to authentication, TLS one-way is server only and mTLS is two-way. Understand, in mTLS or in SSH mutual authentication, it is always the server that proves its identity first. This is there so that clients do not send sensitive information until it is proved the server is what it says it is. Use cases: TLS one way, it's public websites. mTLS is microservice Kubernetes. Kubernetes uses mTLS. You can configure your cluster to use just one-way TLS, but it is not recommended at all. All production implementations, be it managed Kubernetes services, GKE, AKS, EKS, OpenShift, all of these use mTLS. Even clusters configured using kind, kubeadm, all of them also use mutual TLS. Identity verification. Server proves identity. That's understood because it is only one part that has to prove its identity, and in one-way TLS it is always the server. In mutual TLS, both of them prove their identity. Certificate required, only server certificates. For example, when schema was accessing pinkbank.com, only pinkbank.com supplied its certificate, but schema did not. In mTLS, both server and client certificates. So here etcd will also present a certificate and then API server will also present a certificate to etcd. In this section of the diagram, First API server will present its certificate, then SEMA will present its certificate. Security level is strong in one-way TLS, and it is even stronger in mTLS. But Varun, you are saying that we have been using mTLS since the inception of the course. But whenever we are running any commands, we are just typing the command. We are not supplying to which API server we want to connect to there, because there could be many API servers in the world, but we are not specifying any IP address or any identity of the API server. Secondly, we are not providing any certificate. Then how is this communication happening? The communication is happening because of something called Kubernetes configuration file. Now let's discuss what is Kubernetes configuration file and understand what is Kubernetes context. The diagram on screen has three sections: clusters, contexts, and users. This is a kubeconfig file, and kubeconfig file also has three sections for clusters, contexts, and then users. Kubeconfig file can be found in your home directories .kube directory, and it is just named config. The full name for this is Kubernetes configuration file, because this holds the configuration on how to connect to the cluster and what authentication information should be used. But as DevOps engineers, it is not just one cluster that you will be dealing with. You could be assigned 5, 6, or multiple clusters to manage. Then how do you ensure that you are running commands in the right cluster? For example, in the morning you are working with your dev cluster, but by the afternoon you want to work with your production cluster. How do you ensure that the commands that you are running goes to dev cluster in the morning, and let's say prod cluster when you want to work with the prod cluster? How does that work? All of this is possible using the Kubernetes configuration file along with Kubernetes context, and we'll see how this works. So clusters, as the name implies, will have details of all the clusters that you want to deal with. Users imply that what all are the users that are verified for respective Kubernetes cluster. For example, here we know SEMA is a Kubernetes user, that is fine, but SEMA's identity could be different. For example, for dev cluster, maybe SEMA is called SEMA dev user. For staging cluster, SEMA is called SEMA staging user, and similarly for prod. So understand that this nomenclature, the username, could be different for SEMA. But in our example, we are just using SEMA here. And then you have contexts. Context is something that marries the users and cluster. For example, when SEMA as a user switches to SEMA at the rate dev cluster context, then the commands that SEMA will run will go into the dev cluster. When SEMA switches to SEMA at the rate prod cluster context, then the commands will run in the production cluster. As simple as that. And the good thing is, in the context part, you can also supply the namespace. For example, when SEMA wants to work in app1 namespace in the dev cluster, she can switch to this context and then choose the namespace app1, so that all the commands that SEMA is running goes to the app1 namespace of the dev cluster. And once she has done her work with app1 namespace, what she can do is she can choose to have app2 as the namespace for this current context, which is SEMA at the rate dev cluster context, and then she can run her command by default in app2 namespace. And here are the one-liners about all these. User, who is accessing the cluster, which Kubernetes cluster to access, context, how a user accesses a specific cluster, and optionally a namespace. And we'll see all these in the demo section. Kubeconfig, a central file storing users, clusters, contexts, and credentials to manage Kubernetes efficiently. Now you understand the basic skeleton of this file. So what I want to lastly mention is all these are plurals, clusters, contexts, and users, and these are lists, as we'll shortly see in the YAML file. Hence you can have multiple entries under each of them, and we'll see this in a little while. Again, here I'm showing that Seema has her laptop with her, and then she can switch the context based on which cluster she wants to work with. Now let's go to the GitHub repo and see how the kubeconfig file is structured. I'll go to day 32, and here I want to show you example kubeconfig file. I'll zoom in a little. This is a kubeconfig file. API version is v1. Then we have clusters. As you see here, we are defining three clusters: dev, staging, and production, as we saw in the diagram. Users is again a list, but we only have one user in this configuration file, and that user is Seema. Then we have contexts, and in this context section we have defined three contexts, and in each context we have also defined a namespace. So for example, when Seema switches to dev context, the default namespace where she will be running the commands is app1-dev-ns. Based on the requirement, she can change this namespace as per her need. Here is also a default context, which is the current context. For example, if I switch my context to Seema@prod cluster context, then my current context would be Seema@prod cluster context. So it is extremely simple, and this file is highly intuitive once you understand the foundational concepts. Now let's see what is happening. We'll take the example of dev cluster here. So here the name is dev cluster, and the cluster that is dev cluster, its identity is this. So here is the part where we are telling our kubeconfig file, whenever I'm running some commands in the dev cluster, this is the API server I want you to connect to. Understand that API server is the entry point to your cluster. Now, what is certificate authority data? To understand this, I want to take you back to the diagrams. Here, if I scroll down, I have a simple diagram. Here we have a kubectl client, and here we have Seema. Here is our API server. You can think of this as the Kubernetes cluster itself, and then here is the address of the API server along with the port number. And since we have discussed at the very top, let me also do one thing. Let me bring that diagram here so that we can compare side by side. I'll just copy this, and then I will paste this here right on top. Let's understand this diagram. So we were saying in mTLS, both of them prove their identity, Seema and the API server. Whenever Seema tries to make a connection to API server, both of them must prove their identity. So first, let's say what is happening in this section of the diagram. As we have learned thus far in our previous two lectures, in day 31 and in day 30, whenever API server wants to participate in mTLS, then API server will generate a key pair, and that key pair, one will be the certificate and another will be the private key. Once the key pair is generated, then a CSR will be created. What is CSR? CSR is certificate signing request. So API server sends a CSR to the Kubernetes CA, and we'll discuss in our next lecture what exactly Kubernetes CA is, how many other CAs are there in your Kubernetes cluster. But for now, let's say there is a certificate authority that signs API server's certificate. And once that certificate is signed, whenever Seema tries to access this API server presents that certificate to Seema. And then Seema must verify that this certificate is indeed signed by someone I trust. But Varun, we have seen in public key cryptography that to verify that the server was indeed signed by this certificate authority, the kubectl client or SEMA ideally should have this certificate with her. Once she has this certificate, she can verify that indeed this certificate that is presented by API server is signed by the Kubernetes CA. But where is this certificate? I do not have this certificate. And that is exactly what you have saved here. If I go to my GitHub repo again, here we are saying certificate authority data. Certificate authority is CA data. And here what you have is the base 64 encoded public key or the certificate of the Kubernetes CA itself. And that is the reason when API server presented its certificate to SEMA, SEMA could verify that this certificate is indeed legitimate because SEMA already has the certificate file of the Kubernetes certificate authority. So I hope this part is clear. Now let's see what is there in the users section. In users section, we have just one user SEMA, and here is the client certificate data. So let's go to the diagram. I'll just quickly copy this and I'll also paste this here. Now API server has presented its certificate, but SEMA must also present a certificate, and that certificate must be signed by a trusted certificate authority, by a certificate authority that API server trusts. And we will see this in detail how this works in our next lecture. But for now, I want you to understand that the certificate that SEMA presents is available in the client certificate data section. That is how SEMA presents this certificate, and all this authentication part is handled by the Kubernetes configuration file. All the information about clusters, the information about users, the authentication information, all is available in the Kubernetes configuration file. It works like a charm. So now SEMA presents her certificate, and here is the private key of SEMA. This private key never leaves. And again, every certificate information that is in your Kubernetes configuration file is base 64 encoded. And I want you to know that encoding is not same as encryption, and we discussed that somewhere in our course, I think in day 29. I'll just link that in the description. Then let's move to the context. As I told you, context is something that marries the user to the cluster. Here in our example, SEMA @dev cluster context is mapping the user SEMA to the cluster that is named dev cluster. And where is dev cluster? Dev cluster is here. So whenever SEMA switches to the dev cluster, then the user is this and the cluster is this. And that is how it works for all the clusters. So for example, you will have a different certificate authority data for staging cluster. You will have different maybe key pairs for your staging cluster. This is how it works. Now let's go to the terminal and see what is happening with our kinds implementation. Let's go to the terminal and see how this works. So I'll write kubectl config, and this is the command that you will use to deal with your Kubernetes configuration file, to make any changes to the Kubernetes configuration file. And I would recommend never edit that file manually. Even if you want to edit it manually, then take a backup and then work on the configuration file manually. And as I said, the configuration file can be found in this path. If I go to my .cube in my home directory and then press enter, you see here is my config file, and I've already taken a backup of my config file. So if you are manually modifying it, it is recommended you take backup. Even if you are modifying it, using kubectl config, then I would recommend take the backup of this file. So I'll run kubectl config, and then I'll press -H, and here I can see what all commands I can use. So I can use this kubectl config to even delete the cluster, delete the context, delete the user, and this will be deleting the user from the Kubernetes configuration file. Get clusters will be getting the information of the clusters that are available in your Kubernetes configuration file. And if you go to the GitHub repository, you will also find means via which you can deal with multiple kube configuration files, and I will let you read about that, because if I demonstrate everything to you, then this lecture will never end. So for now, let's play with kubectl config commands. So I'll write kubectl config. I'll just write view here. So here with this command, I am just viewing my Kubernetes configuration file. And here, since we already know, we are dealing with a cluster that is created using kind. Kind is Kubernetes in Docker. So here, like we saw, we have three sections: clusters, contexts, and users. Since I only have one cluster created, hence I only see one entry in each of these categories. So the cluster is this, the certificate authority data is this. So as in this is the certificate of the certificate authority that signed the certificate of my Kubernetes API server. And where is my Kubernetes API server? This is the address of my Kubernetes API server. Context, let's first go to users. Users, kind my second cluster. There is one thing that is quite off. What happens in kind, cluster, context, and user, they are all named the same, so that creates a little confusion. But we have seen in our example how a real Kubernetes configuration file might look like. So for now, let's do one thing. Let's create a new cluster in kind and then switch the context, and also see how this file gets changed when we create a new cluster. So what I'll write is, I'll write kind create cluster, and I will name this cluster test cluster. Okay, I'll just name it test. Oh, I think my Docker is not running. Just give me a moment. I'll just run Docker, because even if I run kubectl get pods, okay, now it is running. This command should now run. I'll just close this, and then I'll write kind create cluster name test. Okay, it is working now. The cluster is created. I can write kind get clusters. This will show me the clusters that there are. My second cluster and test is also created. I will now run kubectl config view, and I see this file is now modified. Clusters is a list. I have two clusters now. The first one is named kind my second cluster, and the one that we recently created is called kind -test. So if I now run kubectl config get contexts, then I will see there are two contexts, as I can see here, kind test and kind my second cluster. And here as well, I can see two contexts, and the context I am dealing with is this one. So if I now run kubectl get pods, the command will run in the kind test context. So let's run kubectl get nodes. This cluster was created with the default configuration by kind, hence I only have one node, that is the control plane in my cluster. So let's do one thing. I'll now switch to my kind my second cluster context. I'll write kubectl config use context, and then I will write the name of the context, and the name of the context is kind my second cluster. I'll press enter. It says switched to context kind my second cluster. If I now run kubectl config get context, then I see I have now switched to kind my second cluster, because the asterisk is in the kind my second cluster. And you see one more thing here, there is namespace defined. For kind my second cluster, I have defined a default namespace, which is the default. in here there is no namespace specified. Oh, let's change the namespace in our current context in this kind my second cluster. So let's do one thing. I'll write kubectl config set context current. I want this for the current context, and the namespace that I want is app1ns, and I press enter. It says context kind my second cluster modified. So if I now run this command again, kubectl config get context, I will see this namespace has changed. And if I now run kubectl get pods, it says no resources found in app1 namespace. So if I now want to work with app2 namespace, then I can just write app2 here and continue to work. So this is the beauty of Kubernetes context. When you're dealing with multiple clusters, understanding this file and how it behaves is of paramount importance. So let's now do one thing. Let's delete few things from our Kubernetes configuration file. So we know that we have kubectl config view. I have these details in my Kubernetes configuration file. Now what I want to do is, because I will be deleting the test cluster, and if I delete the test cluster, then it will automatically remove the entries from my kubeconfig file. But for demonstration, I want to show you how can you delete certain things from your Kubernetes configuration file. So what I'll do is I'll write kubectl config delete, and then I have multiple options here. I can either delete cluster, context, or user, and I want to delete all of them. And understand that all of them are named kind test here. Kind test. So let's delete all of them. So I'll write first, I will delete the context, and the context that I want to delete is called kind test. And then I will delete the cluster, and the cluster is also called kind test. And then I finally want to delete the user as well. I have deleted the user. Now if I run kubectl config view, then you only see a single entry for kind my second cluster in all the sections. In the fourth part of this series, we will be looking into how to add user, cluster, and context in this file using the command line. So wait for that. So for now, let's also delete our test cluster. Kind delete cluster, and the name of the cluster is test. What is the command? Kind delete cluster, and yeah, and the name is kind test, or just test, or do I have to add a name flag here? Name kind test. Oh yeah, that was the command. So I hope you have understood the Kubernetes context, and it is extremely important that you understand what we have discussed. If you want to rewatch, do rewatch. Let me see if I want to cover any other thing, and just go to the GitHub repository and you will see a lot of commands that are of use to you. That concludes this lecture. Next up, in part 3, we'll look at how Kubernetes handles internal certificates and private CAs to secure cluster communication. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.